What are Gravitons? In what has become an iconic scene from Avengers: Age of Ultron, Thor politely invites the other members of his team to try and lift his hammer, the mighty Mjolnir, which was resting atop a coffee table in Tony Stark's penthouse. Quite predictably, no one was able to budge it, except Captain America, who managed to stir it just a tad bit. Those who follow Thor either through movies or comic strips know all too well that his hammer is impossibly heavy, and try all they can, almost no one can lift it except for him, which sometimes leads to unforeseen problems. While Thor's hammer and everything related to it is purely fictional, there's a scientific hypothesis that could account for the hammer's incredible weight. Enter Gravitons. Although it sounds like the name of a fictional character, there actually is a villain named Graviton in the Marvel Universe. Gravitons are a real thing, at least in theoretical physics. A graviton is the fundamental particle that mediates gravitational force in the quantum field theory. In other words, it carries the force of gravitation. To put it more plainly, when you throw something up and it comes back down due to gravity, it's essentially the gravitons that pull it down. Apart from the gravitational force, three primary forces exist in nature, all of which have their respective mediating elementary particles. Light, electromagnetism, travels through photons, weak interaction is mediated through W and Z bosons, and the elementary particles carrying strong nuclear force are named gluons. All of these microscopic particles convey the forces that we observe on macro levels. Since gravitational force is also one of the primary forces of nature, it's theorized that it must also have some elementary particle, which is when gravitons entered the picture. However, it's one thing to theorize something and quite another to prove its existence through experimental proof. As of now, the detection of gravitons is practically impossible because we lack a physically feasible detector. Since the force of gravitation is the weakest of all natural forces, it's physically implausible to detect gravitons due to the infinitesimally small cross-section of interaction they have with matter, particles by fundamental interactions. Nevertheless, scientists know a thing or two about gravitons with considerable certainty. First of all, since gravitational force exists between any two particles, irrespective of their position relative to each other, the particles carrying that force between the two bodies must essentially be massless. Furthermore, they must carry a spin of 2, because the source of gravitation is a stress-energy tensor, which happens to be a second-order tensor. These attributes indicate that if a massless particle with a spin of 2 is detected, it must be a graviton. However, what do gravitons have to do with Thor's hammer? A great deal, actually. You see, the force of gravitation is essentially the force that gives anything its weight. Note that the weight of an object is different from its mass, which is independent of all external forces. Consider this. The moon's gravity is 1/6 of Earth's, so if you weigh 60 kilograms here, you would weigh no more than 10 kilograms, 66ths, on the lunar surface. In short, the higher the gravitational force, that is the higher the number of gravitons, the heavier an object weighs, and vice versa. This infers that the mighty Mjolnir must somehow be tinkering with gravitons themselves. A little something about Mjolnir. Thor's hammer, the mighty Mjolnir, is made of a fictional Serbian metal called To Nwo, and thus its composition and properties are obviously foreign to Earth. According to the movie Thor, Mjolnir was forged in the heart of a dying star. On the side of the hammer, there is an inscription that says, "Whosoever holds this hammer, if he be worthy, shall possess the power of Thor." Essentially, this means that Mjolnir carries upon itself a worthiness enchantment, which makes it usable only to those it deems worthy. The mighty Mjolnir, the ability to tinker with gravitons, must therefore lie with the hammer, and, in effect, the metal, itself. Looking at this from our earthly perspective, it obviously seems way out of line to qualify as a property of an element, but to quote Arthur C. Clarke's famous third law, any sufficiently advanced technology is indistinguishable from magic. The metal may appear magical to us simply because it belongs to a planet that is technologically far more advanced than us. So, for now, let's assume that due to its far more superior origins, is what we call magical. Mjolnir's ability to control gravitons. James Kekalius, a physics professor of the University of Minnesota and the author of The Physics of Superheroes, has proposed a very interesting hypothesis regarding Mjolnir's incredible weight. He speculates that since the hammer is made of a foreign and presumably scientifically advanced metal, under proper external stimulus, it must be able to control the emission of gravitons. So, when someone, let's say the Hulk, tries to lift Mjolnir, it instantly calculates the holder's worthiness using some complex algorithm and decides whether or not he is worthy to wield the hammer. If it finds him worthy, he will lift it effortlessly, just like Thor does, but if not, the hammer increases the emission of gravitons to counter the upward force being applied to it. Thus, the harder the Hulk tries to lift the hammer, the greater the number of gravitons it will release and the heavier it will become. Notice, in the following image, how Hulk struggles to lift the hammer, despite applying so much upward force on it. Although we haven't had any success in detecting gravitons, we have been able to detect gravitational waves, which are made of a huge number of gravitons. Physicists are working around the clock to formulate a theory of quantum gravity that will indirectly confirm that gravitons exist. Meanwhile, the superhero realm is busy making stuff heavier than it appears by manipulating these gravitons, or so we assume. If you find this video interesting, then drop a comment and hit the like button and share this video with your friends. And one more thing, don't forget to subscribe. And stay curious and keep learning.